You hear machine learning thrown around all the time, right? But what does that actually mean? What's it doing behind the scenes? Well, today, we're going to pull back the curtain. We're going to break down the entire process, step by step, and show you the powerhouse engine behind some of the smartest tech you use every single day. So let me ask you this. Have you ever been scrolling through a real estate app and seen a price estimate for a house that's not even for sale? It's kind of spooky, right? Feels like magic, but it's not. It is a perfect real-world example of machine learning in action. So, how do they do it? What's the secret sauce behind that number? Yep, the answer is machine learning. See, instead of a programmer trying to write a million rules like, if the house has a pool, add $20,000, which is impossible, we do something way smarter. We just feed the computer a ton of data on past home sales and basically say, here, you figure out the patterns. It learns from all those examples, kind of like how we learn from experience. All right, so where does a journey like this even begin? Well, like any good recipe, it all starts with the ingredients. And in our case, the first, most critical step is the data. Seriously, without good data, you've got nothing. It's the foundation for everything. And this first part really breaks down into two main jobs. First, you got to collect all the information you need. And then, just as important, you have to clean it all up. Because let me tell you, data from the real world, it's almost always a complete mess. So let's bring this back to our house price predictor. What kind of data are we talking about? Well, we'd need to hoover up info from thousands of past home sales. We're talking about the key details, right? Like the square footage, how many bedrooms, how many bathrooms, what neighborhood it's in, and maybe even the year it was built. And that leads us to the part that isn't very glamorous, but is absolutely essential. Cleaning that data. You know, data preparation. This means we have to fix all the mistakes. Like, maybe someone typed in that a house has 20 bedrooms when they meant to. Or we find the same house listed 5 times. We gotta fix all that stuff. It's crucial because there's a golden rule in this field. Garbage in, garbage out. You feed the model bad data, you're gonna get bad predictions. Simple as that. Okay, so our data is gathered. It's squeaky clean. Now for the fun part, the training. This is where the magic really happens. This is the moment the computer starts to learn, digging through all that information to find the hidden connections all by itself. This training stage really has 2 parts. First, there's the actual model training. That's where we let our algorithm study all the data we prepared. But then, and this is key, we have to check its homework. We've got to test it to see if it actually learned what we wanted it to learn. And you don't have to be a coder to get this next part. If you peek behind the curtain, the command to kick this whole learning process off can be something as simple as model.fit. That's it. It's like pressing the go button, telling the model, okay, start learning from this data. But wait a second, how do we know if it's genuinely learning and not just memorizing the answers, like cheating on a test? Well, the trick is we split our data up before we even start. We keep a chunk of it hidden away for a final exam. And a simple command like train test split does all that heavy lifting for us. So here's the best way to think about it. The training set, that's the textbook. It's all the study material and practice problems the model gets to see. But the test set, that's the pop quiz, the final exam. It's full of questions or, houses that it has never, ever seen before. This is the only way to know if it really gets it. So after our model takes its big final exam on that hidden data, we get to grade it. And we might get a result that looks something like this, an accuracy score of 92%. That number tells us exactly how well it did, how close its predictions were to the real sale prices. And hey, 92%, I'd take that grade any day. All right, our model has hit the books, it's passed its exams with flying colors, now it's ready for the real world. This final step is where we put it to work. This is the payoff. This is what it was all for. Now that our model is trained and tested, we can finally give it a new problem. We can use another simple command, something like model.predict, to just ask it a question. We say, hey, based on everything you learned, what's your best guess for a house with these features? And bam, there's our answer. We feed it the details of a totally new house, say 3 beds, 2 baths, 1,800 square feet, and it spits out a prediction based on all those patterns it learned. In this case, $452,000. And just like that, we've gone from a huge, messy pile of data to a single, concrete, useful number. Okay, let's take a step back and look at the big picture here. When you put all those pieces together, you can see the entire journey we just took. So here it is, the whole process from start to finish. You collect the data, you clean it up, you train the model, you test it to make sure it's not guessing, and finally, you use it to make a prediction. That's it. That's the basic recipe behind pretty much any machine learning project out there. When you really think about it, it all comes down to this one powerful idea. Machine learning is a journey that takes you from just having a bunch of data to being able to make an actual decision. And look, this whole process isn't just for predicting house prices. It's the same logic that recommends your next favorite movie, that catches spam in your email, that even helps doctors diagnose diseases earlier. It is truly everywhere. So the real question I want to leave you with is, what's it going to predict next?